So on page 7, we're going to talk about the real numbers. And I think that in Math 7, you have talked about at least most of the words we're going to talk about today. Okay? The real number system. Okay? Some of you are saying real numbers, aren't all numbers real? Well, when you get to be a junior and you take Algebra 2, you will learn about imaginary numbers. So yes, we have to classify these as real. So the real numbers is the set of numbers containing what we call rational and irrational numbers. Okay. As you're writing this down, shake your head yes or no. Have you heard of those words, rational and irrational numbers? I'm seeing some yeses. Okay. So what we do, we classify into 2 groups, irrational and rational. And within rational, we have more subgroups is what we call them. Okay. So first of all, irrational numbers are decimals that never terminate. Terminate, that sounds like kind of a scary word. What does terminate mean? Ooh, to finish. I like that. Okay. Okay, and what does the Terminator do?
Kill people.
He finishes people off, right? So this is like a fancy word for end. Okay, so if you'd rather write end, the decimals never end, and they have no repetition.
So pi.
Okay, so our decimals, they never end, and they never repeat. Okay, so Jacob asked, like the number pi, is pi irrational? Yes, it has a decimal that goes on forever and ever and doesn't repeat. Does anybody else know another irrational number? No.
66. 6.6.
Add 3. 7.
What about the square root of 17? Is that irrational? Yes. Okay. Is 17 one of our perfect squares?
No.
It is not one of our perfect squares, which means the square root of 17 cannot be rewritten as a nice number, so it is irrational. Okay. What would be another square root that would be irrational? The square root of? 20. 20 is not a perfect square, so the square root of 20 would be irrational. Yeah. Now, could I write down the square root of 25? No, because 25 is a perfect square. We can reduce it, because you said the right answer. We're going to be able to classify that as a rational number. Okay? So a rational number, its definition, okay, is basically, hey, it can be written as a fraction. Now, we're not always going to see it written as a fraction. If we see a fraction, we're good to go. But if it's not a fraction, then its decimals would end or have repetition. Okay, so one or the other. So a repeating decimal. Can you think of a repeating decimal?
7.4.
Okay. So like the number 1/3 is 0.333333333, right? The 3 just repeats. So that line on top means, hey, that number's repeating. Okay? And this like dot, dot, dot would mean like it keeps on going and going and going and going. Okay. Let's see. What about the number like -4? Would that be considered rational?
Oh, come on.
Hey, stop. Yeah. Okay. I know it's not a fraction, but -4/1 would be a fraction. Okay. The number 5/7, it's a fraction, so it's rational.
Yeah, I'm cooked.
Hey, you're going to be fine. Okay, let's go back to my question from earlier. The square root of 25. This would belong in the rational category because what's the square root of 25? 5. Okay. Okay. Now, there are a lot more versions of rational numbers than there are irrational. So we have some like subcategories that we can narrow ourselves into. Okay. So I'm going to kind of do this a little strangely. I'm going to do this backwards. I want to start with the natural numbers. Where is it natural for you to begin counting, like when you're a little kid?
1.
When you're a little kid, you start counting at 1, and then the next number is 2, 3, 4. When you're a little kid, this is how the adults in your home teach you how to count. 1, 2, 3, 4, 5. Right? I don't think when you were a little kid you started at 0. I don't think you did. Okay. So now when we move up to the whole numbers, which number or numbers are we going to tack onto that?
2 4.
So we're still going to have 1, 2, 3, 4, 5. Well, yeah. But there's something we're going to put right here.
0.
Oh, 0. The whole numbers. Okay, and then what about the integers? Oh, we're going to have some negative numbers, right? So we still have 0, 1, 2, 3, 4, 5, right? But Channing is saying we are now going to also have our negative numbers. Okay, so you remember before it fell off the wall, I had a number line? Okay. Our integers are basically those number line numbers where we have negatives, 0, positives.
Let's keep it up.
It keeps falling down. I'm going to have to reapply. Okay. Now, do you notice that our natural numbers are in our whole number list? Do you see that? Do you see that our whole number list is a chunk of our integer list? Okay. So what happens is like the number 2 is a natural number, but it's also a whole number and it's also an integer. Okay? So I brought with me my mixing bowls. Okay, we have irrational numbers and we have rational numbers. Okay, now we have irrational numbers, but more specifically, inside of rational numbers, we have integers. Within the integers, we can piece out whole numbers, and within the whole numbers, we have natural numbers. Okay, so here's the thing. If I have a number that's a natural number, It's in all of those other bowls. It is also in the whole number bowl. It's also in the integer bowl. It's also in the rational bowl. It's fit inside of all of them. Okay? So that's the picture that we have right here. Okay? These are like our bowls of numbers. Okay? So I want you to label these. Over here, we have our irrational numbers. Nope, not quite. So just give me a moment. Okay. So the big bowl is our rational numbers. Okay. Huh? Just hold on. Within the rationals, maybe it is an integer. So what this is saying is if it's an integer, it's also rational. Okay? Okay, that's what I was trying to get. Okay? Okay? More narrowed down, we have our whole numbers. And then the very tiniest bowl, the most narrow you can go, is our natural numbers. Okay? So what this is saying is, okay, well, if it's a whole number, it's also in the integer and rational bowl. So if it's a whole number, it's also an integer and a rational. Make it pass and I'll accept it. Okay. I am always going to write down the words. If you want to abbreviate, you do you. Okay. But we basically need to practice figuring out how to name these numbers. Okay. So we're going to go to page 8. If you need to flip back to page 7 at any time to look at those lists, you do that. Okay. So we're going to look at negative 47. Okay. Okay. Negative 47. First of all, is it rational or irrational? It is rational. We could write it as a fraction. Negative 47 over 1. Okay. So we know it's not going to be in this bowl. We know it's going to be at least in this big bowl. Okay. But more specifically, like, can we get it somewhere smaller? So can negative 47 be a natural number? Nope. Can negative 47 be a whole number? No. Can negative 47 be an integer? Okay, so if we put it in the integer, what else is it in? Okay, so I want you to write integer and rational. So Landon has noticed that if it's a negative number that doesn't have a fraction, doesn't have a decimal, we're going to throw it in the integer bucket. Okay, that's good. Then we'll get there. Okay, so 2 3/8. Here's 2 3/8. Okay. Rational or irrational? Rational because it's a fraction. So we know it's going to go in the rational bucket. Can it go in any of these other three? No, because once there's a fraction, it can't be in these 3 smaller bowls. So we're just going to put it in the rational bowl, and that's all it can be. Okay, so if it's a simplified fraction, boom, it's rational. We don't have to think anything more than that. Okay, but notice how I said simplified fraction. Okay. All right. Ooh, it's been a while since we've seen this. What is this?
The distance
Okay, we call it the absolute value. We mean it's the distance from 0. What is the absolute value of negative 9? Okay, so really we're working with 9. Rational or irrational? It's rational. Okay, more specifically, what's the smallest bucket we can put it in? Okay, this is one of our counting numbers, right? 1, 2, 3, 4, 5, 6. If it's a positive number, without a decimal, without a fraction, we're putting it in the natural bucket, okay? So if we put it in the natural bucket, notice how it's also a whole number. It's also an integer, which is rational. It's all 4 of those. Okay, and if you want to use abbreviation, that's fine. Just know that you have 2 different words that start with I. So if you're going to abbreviate with one letter, I isn't going to cut it because you have integer and you have irrational. Okay, square root of 23. Okay, is 23 a perfect square? It is not. So the square root of 23, where is it going to live? What'd you say, Shannon? Okay, good. And in my buckets? It is an irrational number. Since we have a square root and the number underneath isn't a perfect square, that is going to be a non-repeating, non-ending decimal. We don't have time for that guy. Irrational. Don't argue with him. Ooh, so our next one is a decimal, right? A decimal that, does it end or go on forever? Do you see the dot, dot, dot? Okay, so this decimal ends. Okay, and on the page previous, if we have a decimal that ends, where do we put it, Matthew? If we have a decimal, I thought you were raising your hand, but we're still going to go with it. If we have a decimal that ends, on the page previous, what did we write that was?
Rational?
Rational. If it's a decimal that ends or a decimal that repeats, we're going to put it in the rational bucket. That's all it is, just one bucket. Okay, it's the biggest bucket. Okay. 0. Okay, if you look at your list on page 7, where does 0 first appear? Whole number. So we're going to put it in the whole number bucket, but look, it's inside of 2 other buckets. So it's in the whole, which is inside the integer. Landon, put it away. Which is inside, away. The rational bucket. My kids are going to be mad when they try to make popcorn tonight. They use these for popcorn. Okay. Negative square root of 64. Ooh, man, it's a radical. It must be irrational. Landon, why are you shaking your head? What's the square root of 64? Oh. So this is really negative 8. And where did we decide that negative numbers that don't have decimals or fractions live? Rational, which is also, it is an integer, which that bucket is inside of rational. So we're going to write integer and rational. Okay. Okay, this is a decimal. What does that line on the top mean? It's repeating. So this means it's repeating. And this means it keeps going. And it's okay if we keep going on forever if we're repeating. Where did we write that that's okay? What kind of number? What kind of number repeats? A rational number, it is okay to repeat. Okay? And rational is the big bucket. There's no other buckets it's inside. Okay? All right. Oh, cool. We have a fraction. So it's rational. We're done? No, because what's negative 24 over 6? Yeah. This is negative 4. And yeah, it's rational, but what bucket are we putting it in? We're putting our negative number in our integer bucket. So it's integer and rational. I'll tell you what, I'm working pretty hard up here, and if you're not with me, this is really going to stink for you tonight when you do your homework. Cubed root of 8. The cubed root of 8 is 2. And 2, where's the first time 2 appears in our charts? It's one of our natural counting numbers. And if it's a natural number, then it's also a whole number, which is also an integer, which is rational. Okay. Now, like I said, if you want to use abbreviations, you go for it. Okay. That's fine. But I will promise you on your quiz, you'll have to answer like this. Here's a number. Tell me the buckets it's in. Okay. Now, on your homework, you're also going to have something like this. And what I want to do is I want to just look at a few of them and then get you started on your homework so it's not like all for at home. But basically, we need to figure out what buckets to place these in. So the first one I want to look at, let's look at A, negative square root of 50. Is 50 a perfect square?
Yeah.
What squared is 50? 5 squared is 25. So 50 is not a perfect square, so it's going to live in the irrational bucket. Okay. Now, B is a decimal that stops, which means it's rational. A decimal that stops is rational. Okay. We're not on page 10. We're still on page 8. I never said anything about page 10. I never said page 10. No, I said I want to do a couple of these before I get you started. Now, on letter C, 8. Where would that live? Natural. So you would put C right here, and then I can see with my eyes that it's also in these other buckets, but you don't need to write it in there. If you just write it in natural, we can see that it's in those other buckets. Okay? What about my negative 11?
That's an integer.
That is an integer, so I'm going to write it in integer, and it also lives in the rational, but we can see that it's in that bucket. Okay? What's the only number that you're ever going to write in the whole number bucket?
The ones that are whole.
Okay, the only one would be like I, which is 0. You have, 0's the only number that's whole that's not natural. So it's the only special one that you would put in that bucket without it being in something else. Okay, now you can turn to page 10. And what I'll have you do on page 10 is mark cross off number 6. You're welcome. And I'll have you do the rest of page 10. 1 through 12, but you're skipping number 6.